Hi, I'm Alison Robertson. I'm a field crops extension pathologist at Iowa State University, and my lab has been working on cover crops for the last 10 to 12 years. We started working with Tom Casper. Tom had a question about why we sometimes got reductions in yield of corn when it was following a cereal rye cover crop. And so he approached me and he asked me if seedling disease could be playing a role. And so we got together and we got some funding from Iowa Nutrient Research Center, and we started to investigate if corn was more at risk for seedling disease following a cereal rye cover crop. So Tom and I started to work together to try and understand why we were getting this yield reduction with corn following a cover crop of cereal rye. We knew that there were a lot of farmers out in the state who were hesitant to plant corn or hesitant to even try cover crops because they were worried about their corn yields after those cover crops. And so we really wanted to get to the bottom of what's happening in this system. And so I started working with Tom, and now for the past 10 to 12 years we've been working in the system trying to understand what are the factors that are playing a role so that sometimes we see this yield decline of corn following a cereal rye cover crop. And I'm a pathologist, so I'm interested in seedling disease. And one of the first things we did was we were able to show that cereal rye is a host of seedling pathogens that can also infect corn. Because of that, our first experiment that we did was we wanted to look at, could we separate the cereal rye from the corn in time? And so what I mean by that is, what happens if we terminate the cereal rye at different dates before planting that corn? Can we reduce the risk of seedling disease, and can we mitigate that yield drag that we're getting? And so from our first set of results, we were able to show that yes, we could. By separating the corn in time from the cereal rye, we could reduce the amount of seedling disease and we could mitigate that yield drag. So from that, we came up with a recommendation that a cereal rye cover crop needs to be terminated at least 10 days before we plant corn. The problem with that recommendation is that sometimes a farmer can't get into the field to terminate the cereal rye 10 days ahead of planting the corn. This year is a perfect example of that. And so the next set of experiments we did was we looked at how does planting green affect corn and that corn yield drag. And what we were able to show is that when you plant corn into a green cereal rye crop and then you terminate that cereal rye at or soon after planting, that you increase the risk of seedling disease and you also get yield drag with that. In this trial that I'm standing in front of today, that was one of the treatments that we have in this trial, is planting green. And so behind me, you can see the cereal rye, a lot more biomass than we ever expected, thanks to an exceedingly warm February, and then rain the last 4 weeks, which meant we couldn't get into plant. But a lot of biomass here, and we know that that is going to increase our risk of a yield drag, and we're probably going to see more seedling disease with that. In case you're wondering, we had no problems planting corn into this much cereal rye biomass. So planting hasn't been the issue. I'm really interested to see how what the crop will look like in another 4 to 6 weeks, because I don't think it's going to look that great. It's corn, right? Corn is a princess. Soybeans, fine. They're so resilient, but corn, yeah, corn is a princess. So I talked about how we can reduce disease by separating a host crop from the pathogen in time, but we can also separate the host crop from the pathogen in space, right? And we know the pathogen is coming from the rye roots, okay, and coming onto the corn. That's what our previous research showed us. And so we did some work, again funded by Iowa Nutrient Research Center, where we socially distanced the corn from the cereal rye, And we were able to show that by socially distancing the two crops, that we reduced or we mitigated the yield drag, and that was associated with lower seedling disease as well. You're probably wondering how we socially distanced the two crops. So we drilled the rye, and then what we did was we plugged one of the drills. And so then we had 3 rows of rye planted, and then we would have the drill plugged, and when that row where the drill was plugged, that's where we would plant the corn. So if our corn's on 30-inch rows, we have 3 rows of rye running in between that. That means the corn is separated from the rye by about 3.5 inches. We're drilling on 7.5-inch rows. Then another thing we did was we plugged 3 of the drills and then just plant, and so that meant that we were now planting the rye on 30-inch rows. So when we plant the corn immediately in the middle of that, now the corn is 15 inches away from the rye on either side. When we did that, we had as much seedling disease as we did in our no rye cover crop, and our yield was almost as good as where we had no cover crop. So we were really pleased with those results. But the problem with that experiment is, why are we planting cereal rye? We're planting cereal rye for all the benefits that it gives us, right? It protects our soil from erosion, improves infiltration, takes up that excess nitrate in the soil. And if we're going to socially distance the rye from the corn, if we're planting rye on 30-inch rows, that means we're planting 25% as much rye as if we'd planted, on 4 drilled rows every 30 inches. And when we're plugging one of the drills, then we have 25% less rye on the surface. And so because of that, we were just concerned that recommending to farmers that they plant rye on 30-inch rows, right? We might be negating the benefits of that cereal rye. And so I got together with Peter O'Brien. Peter is a research agronomist, but he's able to study things like infiltration and erosion. And so we got together to work on this project that I have here behind me. And so what do we have in this project? So in this project, we have the rye socially distanced from the corn. We have the rye planted in 30-inch rows, and then we also have where we've plugged 1 drill, and so we have 3 rows of rye in between the corn. So we've socially distanced it. But then the other thing that we wanted to do was we also wanted to plant green or terminate at least 10 days before planting the corn. So put in that timing, because what we're hoping is by socially distancing the rye, we can then plant green, because that would be really helpful to a farmer, right? If he can terminate and plant on the same day. And so that's the goal of this experiment behind us. We're trying to see, can we socially distance, still plant green, mitigate the yield drag, and reduce the amount of seedling disease. So the kind of data that we're going to collect to see if this is working is, we're going to come out at about V2, V3 is when we normally like to come out. We dig up seedlings then, and then we wash them, and we look at the roots and the mesocotyl for symptoms of root rot, which would be seedling blight, right? And we'll also do stand counts to see if we lost any stand from seedling disease. Other things that we'll be doing is just measuring the height of the corn, biomass of the corn, looking at greenness of the corn, measuring that, and looking just to get a measure of how vigorous that corn is. Towards the end of the growing season, we'll come in and we'll count plants with barren, so no ear or very small ears, because you can imagine if you get a small ear or no ear, that reduces your yield, right? So we'll also look at stalk rot, and obviously we'll collect yield data as well. So when we collect this kind of data, we collect it from a known area in the plot. So for example, we'll collect cereal rye biomass. We'll collect it from a meter of row, just over 3 foot of row. And then depending on how much biomass we have in that meter, we're then able to convert it to how much biomass would be on an acre. So the same as when we go out and we collect our seedlings. We'll collect our seedlings from a meter of row. We'll collect 5 seedlings. We'll find out what the average root rot is, and then we'll be able to come up with an average root rot per acre for that field. Now I've talked about the pathology and the agronomy in terms of corn growth that we're doing, and I'm going to hand off the mic now to Peter O'Brien, and he's going to talk about some of the data that he's collecting.
Hi, my name is Peter O'Brien, and I'm a research agronomist with the National Laboratory for Agriculture and the Environment, and that is located on Iowa State University's campus, and it's part of the USDA Agricultural Research Service. And a lot of my research program investigates cover crops and what sorts of benefits and, of course, potential drawbacks come along with that. Yeah, so I got involved with this project because I came in and took over the research program of Dr. Tom Casper. And he did a lot of really good work denoting the benefits of cover crops in our corn soybean systems. But they also showed, as Allison described, some potential for yield drag. And what we really want to do with this project is determine what is causing that yield drag, and if the strategies that we're employing to try to mitigate that are doing anything to the benefits that we see from the cover crops. So some of the benefits of cover crops, as the name implies, it's covering the soil, and so it's protecting that soil from intense heat. It's changing the way that water evaporates from that system, so maybe you're holding a little more water. It protects it from raindrop impact, and so it's not breaking up the soil particles and risking erosion. Also slowing down on slopes, it's slowing down water movement, and therefore improving infiltration. Another really valuable benefit of cover crops is just the active root growth that's going on, and so it's promoting a lot of soil health characteristics with those different pore networks. And so in addition to increasing infiltration, sometimes it's able to increase the amount of water the soil can store. And so in a year like this, when we get a lot of rain early in the season, hopefully beneath that cover crop, it's holding on to that water that then the corn can use when it needs it later in the year. So some problems we have this year with this really large amount of rye biomass that we've grown is, I talked about some of the benefits of having the cereal rye for water. But when we grow this much, we worry that maybe it's taken up too much water. So maybe too much of a good thing, that it might deplete the soil of water from the corn. There's also a big risk of once this cereal rye all dies off, it lays down on the soil, it's decomposing over the course of the year, and sometimes that can mess with nitrogen dynamics and then kind of hurting the corn in terms of nitrogen availability. So Dr. Robertson did a really good job describing how we can mitigate crop yield declines by strategically managing the cereal rye by either spatially separating it or separating it in space. But in both of those circumstances, we are either reducing the amount of rye we're putting onto the field by 25% or 75%, or we're reducing the amount of time that rye has to grow in the spring. And you can see out here, or in some of the B-roll, we can see in this trial that even that 2.5 or 3 weeks of growth in the spring can result in huge biomass increases. One really important way to determine if the rye is providing these ecosystem services, despite changing our management, is to measure just how much cereal rye is out here. And so as we have more cereal rye biomass, again, it's capturing more of that nitrogen from the soil profile, keeping it out of the tile drains, which is where we do not want it, and then holding it there on the field for the corn later. So we collect rye biomass immediately before termination. So for this trial, we collected at 2 different times because we terminated at 2 different times. And we expect to see really big differences in those rye biomass numbers this year. In addition to measuring how much rye biomass is there and actually how much nitrogen is within that biomass we collect, we also buried some little PVC resin lysimeters And so what that's going to tell us is any amount of water that's going down into the soil profile, about 2 or 3 feet is where we buried them, water that goes through that lysimeter, nitrogen is removed from that water and held in the resin. And so this is kind of acting like a proxy for what might be lost through the tile drain. And so that's, in this area, a really important concern and a really important consideration for why people grow cover crop. Yeah, so in year 1 of the experiment, we found not as exciting results as we might want to see with our different strategies for the rye cover crop in terms of nitrogen in those resin lysimeters. But what we did find was at least one important finding, that having a cover crop of any sort, separated, not separated, early terminated, late terminated, resulted in a reduction in nitrogen in those lysimeters, and therefore a reduction in nitrate losses in the tile drainage. So in addition to understanding what's going on with nitrogen dynamics, we really want to assess how well these different strategies are allowing us to reduce soil erosion, which is a really important benefit of cover crops. And so we're going to come out a week or 2 after corn planting, and we're going to conduct rainfall simulations. And so we're going to rain really pretty intensely on these plots, both the controls with no cover crops and across the spectrum of our treatments. And we're going to be collecting how much water comes off, so we can kind of understand things about runoff and infiltration. And then we're going to see within that water how much sediment is there, how much soil is moving down the slope, and to kind of understand our protection from erosion using these metrics. So this project is a really exciting one to be a part of, because it's starting to get at some of these questions that are creating barriers to adoption across the state. People are concerned about, if I'm planting cover crops, am I hurting my corn yield? Am I changing nitrogen needs in my soil? And so by expanding on our current knowledge of what we know in terms of yield disease, what we know in terms of cover crop benefits, we're kind of building this toolbox for different situations. Farmers have different needs. So if we can identify some different strategies for them to employ and understand what's going to happen, that's a really exciting thing for us and a really useful thing for the growers in the state.